Okay, so what would happen if I take y equals x squared, which looks like this, and then I go to second graph here, y equals, and do a negative of the x squared right there. Lots of ways we can look at it. Again, I put it in the graphing calculator, or graphing device of some sort. What I find is this graph turns out, well, all the points, you know, that's got x squared, but then it negates all those x squareds. So all the y values now are negatives instead of positives. Here's what happens. What happens is, basically it flips it over, right? It flips the graph over the x-axis and now makes it, instead of upward, an upward parabola we would call it, now it's downward. Another way to think of it. But in terms of technical, what we technically say is that our graph has been reflected through the x-axis. Flips it over. To put it in more layman terms, I guess. It flips it over. What was here is now flipped over. Okay? And so a minus, putting a minus there in front of the function flips it over. Reflects it through the x-axis is a little more accurate, I guess you might say. So if I've got g of x, so putting it kind of in the terminology we had before. If I've got a g of x function, it's the negation of putting a minus in front of it, another function. That's going to reflect it through the x-axis, flips it over, okay? So that reflects the graph of y equals f of x through the x-axis. Flips it over. Okay, flips it over. All right, now that's that's what it looks like for x squared. What if I did y equals minus x cubed? Minus, the x cubed graph, that's a little different. Well, let's put y equals x cubed here on this. In fact, let's put a little dotted here. Roughly speaking. Yeah, the dotted one there, that's x cubed. Well, now I've got minus x cubed. So what's that do? Well, technically what we say is it reflects it through the x-axis. What's that going to do to the x cubed graph? Well, the x cubed graph, we've got part of it below and part of it above the x-axis. This part's above the x-axis, this part's below the x-axis, so guess what it does? What? It flips both of them, yeah. It flips the part that's below the x-axis above the x-axis, and it flips the part that's above the x-axis below it. So this part gets flipped up, this part gets flipped down. So it is a reflection through the x-axis, but any part that's below the x-axis flips up, and any part that's below the x-axis flips down. Okay? All right. Now, what would this be? Y equals the negative absolute value x plus 1, the absolute value of negative, the negative of the absolute value of x plus 1. Well, again, we've got a combination transformation here, right? What is the transformation?
It's gonna go up.
Is that going to make it go up one? Where is it at? It's on the inside, right? And an inside makes it go right or left.
Left.
And plus one makes it go left, yes. So the plus one here makes it go one left. And that would be, again, the order here, the order that we go, inside first, right? And then we do the negative. And then the negative flips it, right? Reflects through the x-axis. It's a flip. So we're going to move it one to the left and then flip it over. Well, all right. So here's what that looks like. So here's y equals the absolute value of x. Let's move that one to the left and then reflect it through the x-axis. So one to the left, we put it over here, and then I reflect it. Well, that's going to flip it over, and so now instead of a right side up V, now it's going to be a downward facing. I guess we could call it upside down V. For ways of saying it. Like this. Again, if you follow some points, so of course that point doesn't get reflected, but if we follow this point, one to the left, and then it flips it down, so now this point's down here, and this point's over here, so you wanted your 3 points, and how it looks. One to the left, and then flip it over. So really what that means, if this point, we move it one to the left, and so it's at +1 still, and so it's going to be at -1 down here. This point, just to follow another one, this point's at 2, -2, 2. But if I move it one to the left, it's still at 2, but now it's -2. So that's what the flipping over will do for it. It just changes that y value to its opposite, from +2 to a -2 on the flip side there. Okay? Question or concern? All right.
When we're figuring those, we could just change the slope from a positive to a negative, like for when we're checking our graphs.
Say that again.
We can change our slope from positive to negative when we're trying to check the new graph that we're putting.
What do you mean the slope?
Well, say if the slope is, well, whatever the slope is for the first one, we can make it a negative, you know.
You talking about for this one?
Yeah, any of them.
Any of them?
And shouldn't you be, I mean.
Well, I mean, that gets a whole, yeah, you've got 2 lines here, and so you've got, one has this slope and one has that slope.
But you could trade them.
It sort of does flip over the slope. I see what you're saying.
Yeah.
I have a quick question.
Okay.
On the points where you said you want 3 points for each one.
Mm-hmm.
When we do that, are you wanting us, like on the original one here, so the absolute value on the top, am I going to take 2 points on the original one
Yeah.
and then plug in what my new points are going to be on?
Yeah.
Okay.
To get these points, yeah, that's why I put those
Right.
on there, you know, just kind of showing those. That one flips one to the left and then flips down to the -1, so it'd actually be at -2 is where the x value is. So yeah, something like that. The 0, of course, the -1 is at 0, and then this point, one to the left, you're at 0. So those are the 3, and you know you can follow those points along or use the equation. It's at -2, then it should be at -1. Yeah, that's what I get here. -1, I'm at 0, and 0, I'm at -1. So yeah, just give me 3 points to make it nice, a nice shape, instead of making it too wide or too narrow. All right. Okay, so what about this one? g of x equals 3 minus the square root of x plus 4. About as tricky as we could make this one. Yeah.
We'll go
What do we got?
left 4.
What's the transformation?
Left 4 and up 3,
And now say flip.
and then flip.
Yeah, so again, need to go to the inside first. It's kind of like parentheses, do the inside first. So we got the 4 left on the inside. Now, which would be next after that?
3 up or flip.
3 up or flip? Well,
Flip.
the minus here is kind of next to the inside. So yeah, you do the minus here next. So that would be the flip. Yeah, reflect through the x-axis, and then 3. What does that 3 do? Up 3? Up 3, yeah. Why is it up 3? It's on the outside, and it's a positive, yeah. Even though it doesn't say plus 3, it is a positive 3 right there, and it's on the outside. So yeah, you're right, 3 up is the transformation. 4 to the left, then a reflect, and then 3 units up. Okay, so let's think about that. Here's my square root graph. So you move that 4 to the left. Reflect it. All right, so what's the reflect going to do?
Put it on the left side.
Flip it over, yeah. So now, instead of being this up thing, it's going, yeah, it's turned it over. So now it's, before we move it 3 up, it's looking like that, isn't it? And then I'm going 3, but then I need to do 3 units up. And so that reflection now moves up above. See, the order here is important, because if we don't do it in the same right order, we get the wrong looking thing. So it's 4 left, then reflect, and then 3 up. So it actually looks like this.
So start on the inside and work your way out.
Yes, inside, work your way out. That's exactly right. So yeah, if you're looking for points, that's 0, 0. You got 4 to the left, and then so it's up here now at 4. So it'll be negative 4, sorry, negative 4. And positive 3, sorry. Because we just went 3 up, not 4 up. Okay. The 1, 1 point, so it's 4 to the left, so now it's here at negative 3. Well, that put it at 2. Yeah, 2. Another good point would be 4, 2, so I guess that's at, actually I should put that there. Get that point. Because if we move this 4, 2 point, 4 to the left puts it right at the x-axis. So. Yeah, 0. Put a 0 in there. I mean, you can do whatever 3 points, plug in 3 x values, but get some good ones that it helps out. 0, 1. Question or concern?
Does not go below the x-axis on the.
Yeah, it will eventually. It will at some point. I don't know.
But not in the diagram.
Not in mine, because I don't know exactly where it was going to go across there. I didn't figure that out, but probably somewhere. I think it'd be 13, wouldn't it? If x is 13, because that would be the square root of 9. 3 minus 3, so it'd be at 0. So it would be out there. You don't have to figure that out. Anything else? All right, now, one other thing before, just FYI, this will help us more later. One other type of transformation, and that is, what if I do a number here multiplied by the function. X squared and then 2x squared. See how we describe that. Here's my y equals x squared graph. Y equals 2x squared. Well, y equals 2x squared, if we plot it, punch it up on the calculator, here's what it's going to look like. Basically what it does is it multiplies, if you think about it, whatever the y value here, it's going to multiply it by 2. So if the y value here is 1, the y value over here would be 2 times 1, would be 2. The y value over here is 4, the y value over here would be 8. So it multiplies each y value by 2. Well, what that amounts to, so my y equals 2x squared is right here. How would you describe that? Well, it didn't shift it up 2 because this point is still 0, 0. What this did, the way they typically describe it, it's not a shift, it's a stretch. We have stretched the graph by a factor of 2 here, okay? Now, in this particular case, more layman's terms, I guess, what happened to the graph? It went from here to here. It made it more narrow, okay? In this particular case, it made the graph narrow. Now, that can be a little misleading because it won't always make it narrower. And that's why they like the stretching term better, but stretch by a factor of 2. In this particular case, it made it narrower. Like I said, it won't always be, you couldn't always describe it as being narrower, just in this particular case. In other cases too, but in other cases it won't be narrower, but I'll show you in a second. All right, stretched by a factor. So a number in front, multiplied in front, stretches it by that, whatever factor it is. All right, so if it's 3, it's going to stretch it by a factor of 3. Now what if it's a half? Stretching it by a factor of a half. What do you think that would look like?
That would make it wider.
Makes it wider, yeah. In this particular case, it makes it wider, but so here's y equals x squared. And so if I look at y equals 1/2 x squared. Well, the 1/2, so it's going to stretch it by a factor of 1/2, which we would probably describe that in this particular case as it's going to make it a wider graph instead of a narrower graph. And that's what it does, is it halves all the y values. But technically speaking, it stretches it by a factor of a half, which means, yeah, it spreads it out wider in this particular case. Now the reason I keep harping that it's wider in this particular case is look at this. If you look at the square root graph, that's what it looks like. If I do y equals 2 square root of x, well, stretch by a factor of 2, is that going to make it wider or narrower? Well, if I stretch it by a factor of 2, doesn't it move it up here? Would you call that wider or narrower? I would call that wide. So you have to be careful with the wider or narrower thing, but it works for the x squared graph perfectly fine, and we'll use it later on. We'll use that. We'll do a lot more with the x squared graph, and wider and narrow is perfectly fine. But just be aware here, it's stretched by a factor of 2, so it actually comes out looking wider for your square root graph. It kind of works the opposite there, so just be aware of that.